1 in 6 people worldwide have a significant disability. In terms of education, persons with impairments face notable barriers. Introducing inaccessible technology in education will lead to even more issues. This thesis explored the accessibility of 360-degree platforms. 360-degree videos and images allow the users to access all of the different angles of the filmed environment and move around through predefined teleportation points. The media is available on VR headsets and desktop and mobile devices. This thesis consists of 3 parts: theory, which includes derivation of guidelines and assigning each guideline to its corresponding user group. Then in the practical part, I introduced 3 different learning platforms. In each platform, I created a demo course containing as many accessibility barriers as possible. I tested the accessibility of those courses using the compiled guidelines, and I defined the found barriers. In the end, I provided recommendations for developers and workarounds for content creators based on the findings of the study. For defining the user groups, I used official statistics. The final user group categories are persons with visual, auditory, mobility, vestibular, cognitive, and speech impairments, and photosensitive epilepsy. To gather the guidelines, I used a deductive approach, starting with a set of recommendations that apply to a broader spectrum of applications, and then adding further requirements that specifically apply to immersive technology and 360-degree environments. The base document used for derivation is the EN 301549. The final set of guidelines includes 80 requirements and 11 categories. The subcategories were captions and transcripts, volume, signing avatar, audio source, controls, sensory characteristics, text adjustments, text alternatives and speech output, audio description, contrast and colors, magnification and legibility, keyboard, gestures, input, voice, speed, triggers, camera, speech, sound, orientation, guides, safe space, simple language, assistive technology, and time limit. The 3 platforms I tested were Thinkling, Uptail, and ImmerseMe. To construct the demo courses, I inverted the guidelines in order to define barriers I would want to implement if the platform allows it. All 3 demo courses fulfilled less than 50% of the requirements. The user group facing the most barriers are users with visual impairments, with 18 common barriers across the 3 courses. However, proportionally to the number of guidelines, users with photosensitive epilepsy are most affected. Depending on the course content, the percentage of unfulfilled barriers can go up to 100. To summarize the platform's results, Thinkling's most notable barrier is the lack of captions or signing avatar feature, making the content inaccessible to persons with hearing impairments. Uptail does not support keyboard interactions both in VR and in browser. The whole content of the course is also inaccessible to screen readers. This causes major barriers for users with blindness and low vision. ImmerseMe has a bug that appears at the end of the course. It is essentially a glitch which can pose a trigger for someone with cognitive impairments or photosensitive epilepsy.